All right. Well, thank you. And thank you everybody for joining us today. One of the nice things about doing a little bit longer format, doing a 3-hour session as we're doing today, is it does give us an opportunity to dive a little bit deeper into some of the important areas that we can't touch on in a shorter format. And we've realized that doing the post-processing, going from where Lewis had sort of shown you having the colorized 3D point cloud to generating some output product is an area that there are people coming into UAV LIDAR that may not be experienced in that area. So we're addressing that on the training side. We've put together an 8-hour web training course that kind of picks up from the 2-day training that Madeline mentioned to go through some of this. And I'm going to spend the next half hour to kind of show you some of the things that you can do in TrueView EVO. I'm going to focus a lot on doing a bare earth extraction, which is a very common thing that you want to do with these sort of point cloud data sets, of course. A quick overview, what I'm going to cover over the next 30 minutes. I do have a few slides I want to go to. I'm going to do a little bit of theory because I do think it's important when you get to this point with your data set, you need to have a little bit of background on what's happening when you do a ground classification, when you run what we call an adaptive TIN algorithm. But it's just a few slides to give you some idea of the terminology and what I'm going to be talking about. Then I'll just hop into the software and go through doing a ground classification, explain a little bit of how we implement that through point cloud tasks, some of the review and manual cleanup, and so on and so forth. If you are an experienced LIDAR person, then this will be very familiar to work that you've done either with UAV LIDAR or fixed wing LIDAR and so forth. So let's just dive right in. So you've got that nice colorized point cloud, but your client needs a bare earth dam or they need contours of the bare earth. You're going to have to do a ground filter. And we implement that in TrueView EVO using a very standard algorithm. It's called an adaptive TIN ground filter. The main thing to understand, there's 3 parameters I want you to understand to take away from this, the way the algorithm works. It starts by creating a seed surface. We have to start somewhere, and that seed surface is defined by a grid. So seed sample distance, I want you to remember that term, that's basically the size of that initial grid that we use to get that initial surface. The algorithm is then going to build a TIN surface from that, and it's going to go through and look at the other points and compare each point to that seed surface using an angle and distance test. So there's going to be an angle and distance parameter. I want you to remember that. If that candidate point passes those parameters, then it's added to the surface. If it's not, it's ignored. And the algorithm then iterates. It rebuilds the surface with all the new points it added, and it keeps going until it reaches a stop state. All of this is implemented and actually pretty simply within TrueView EVO to the point where you can just run it automatically. But we want to talk a little bit about how that actually works, because you will find that, as you start to get more comfortable with it, you will start to take a little bit more control over how the algorithm runs. So as I mentioned, the first parameter, that seed surface, is built by placing a grid over your data. And then the algorithm just takes the lowest point in each cell and says, this is a ground point. There's some things that related to that can have some impact on your results. We get into that a little bit more in our training, but basically you're looking at a sort of a low pass first estimate of your ground surface. The one issue that's important to be aware of is that seed surface, that seed sample size does impact or does interact with, for instance, like buildings on your within your project site. If I happen to have a building that's larger than my seed sample distance, I'm going to have issues. You can see here that cells A and B, they're fully contained on the roof of the building. Just automatically, I'm going to end up with ground points on the roof of that building. I'm going to get a bust in my ground surface. So you want to set your seed sample size to be a little bit bigger than the largest feature in your data set, the largest building in your data set. Again, there's subtleties we could go into, and we do go into more in the training about that, but that's the way to think of it, a little bit bigger than your biggest building. The angle and distance, I'm not going to spend too much time on these. You will get copies of the slides so you can look into these, but basically the angle to make sure that the point that you're looking to add to the ground is close to the surface. For TrueView data, we've really spent a lot of time looking at this, and we think that 2 degrees is a very solid, good default setting for TrueView 410 data. You get very nice results with that 2 degrees. These are user adjustable should you need to play with it, but we really recommend that 2 degree default. And then there's a distance parameter as well. You'll see me talking about that. Again, for TrueView data, about a 1/2 meter is pretty good. And the main purpose of this parameter is just to make sure on larger triangles, it's not going to jump upwards in any large way. So a little bit of theory there, but let's move on to the actual showing of this in the software. So you guys still now seeing my TrueView screen?
Yep, we can see it.
Perfect. Okay, so this is the same site that Lewis was showing you, the shop site, and I've got the point cloud. It's all gone through all the processing, the TrueView processing. It is actually colorized, and I've got my by flight line stuff set up there. What I'm going to be doing over the next 5-10 minutes, and again, I just want to kind of orient you a little bit, is running some point cloud tasks. So what we call PCTs, or point cloud tasks in TrueView EVO. And this is actually, one of the real benefits of building the TrueView workflow into our LP360 architecture is you get full access to all of those point cloud tasks that have been built up over the years for working with point clouds, for doing sort of point cloud analysis and so forth. I'm not going to go through in depth, all of the details of what's available there. Just be aware there's basically a default library of tasks that come with TrueView EVO, and then these can all be customized, so you can see all of these numbered ones are ones that I've built up for my own analysis. You can create these libraries, you can import and export, you can share them with colleagues, exchange them with customers and clients. It's a very effective way for building up a library of analysis tools, macros or scripts essentially, that let you do really interesting and useful things with the point cloud data. So when I'm talking about point cloud tasks, I'm talking about running a script or running a macro on that. Now, I have a lot of these tasks. We have some good grouping tools in here, so I can just limit the view of what I'm looking at over here on the left side. I've just got, various different categories. I just really want my TrueView point cloud tasks. And you can see I've got a list of about 8 of them here to let me do the things that I want to do with TrueView. Now, I'll just mention just real briefly, because I know we do have some experienced LIDAR people here. If you're coming from the airborne side, if you've worked with airborne or helicopter data, you're probably familiar with doing some low noise filtering at this point. It's related to how those seed points are picked and wanting to get rid of low points first. We actually don't recommend that with TrueView 410 data. There's very little low point noise, that is significantly lower points that are going to bust your seed surface in the data. The data is quite clean. There is, of course, shot noise, and we'll talk a little bit how we deal with that a little bit later. But generally, we're not going to do any noise filtering unless we notice in the data set we've got some issues to work with. We can actually move directly on to doing the ground classification. So to do that in TrueView EVO, it's actually really very simple. You've got a standard TrueView ground using the default TrueView parameters I mentioned. That's already configured for you as a point cloud task. You just select that. And that's going to bring up this window here. These point cloud tasks are interactive. As a user, you can go in and change parameters and configure them the way that you want to be. For the most part, for a ground classification, if you're using the default parameters, not really a whole lot that you need to change. So I'm not going to change many of these parameters. With any of the point cloud tasks, of course, it's essentially think of it as a filter. I need to give that filter some import points, so some source points, and then tell it what class to put those points in if they pass the filter. If you're not familiar with classes, that's just a standard thing that people work with LIDAR data. There's a standard class table that's part of the ASPRS LAS standard. Class 2, for example, means a ground point. Now, there's a lot of power in this. Should you need to do some additional tweaking or configuring the point cloud tasks. I'm just going to pull another window over here. I can find it on my other screen. Yeah. And don't worry, there's a lot going on in this dialogue. Don't worry too much about it. This is our live view. It's a way of looking at how you filter the data, and you can see it's very powerful. There's a lot of different things that you can filter on when you're setting up, what source points you want to use. we're obviously going to use a particular class, the unclassified class. But what I wanted to point out here is very standard with LIDAR. You want to take advantage of the fact that you have multiple returns with the LIDAR data. And the Quanergy M8 that we use on the 410 has 3 returns, which is quite unique for that class of LIDAR. Often they only come with just 1 return because they're designed for automotive and other applications where multiple returns aren't as useful. But the Quanergy's got 3 returns, and we can use that as you would with any traditional airborne LIDAR to limit the points that we think are on the ground. If I've got 1 return and I have 2 other returns after it in the same pulse, then pretty much sure that first return is not on the ground. So I can ignore that and filter that out of here. A lot of other things that you can do there in terms of filtering on all sorts of parameters. A very powerful tool. The only thing that I really need to tweak on a sort of project by project basis for TrueView data is that seed sample distance, as I mentioned. This data set's in meters. I've set this to 25 meters. Let me just go back and look at the tin surface here so it's a little bit easier to visualize. I do have some buildings in this area, and the 25 meters is just a little bit bigger than the biggest building I have in there. Having configured the point cloud task, I would go run it. Typically, I would run against the whole data set, the whole project. You can, run it just in certain areas. You can run it against certain boundaries, polygons, if you have certain areas that you want to run. Again, a lot of power there that we get more into in the training. This particular ground classification for this data set takes about 2.5 minutes to run. So I'm just going to go switch. I've got the results already pulled in from running it earlier. So I'm just going to go switch to that LAS layer. The coloring here, by the way, if you're not familiar with, again, with classes within LIDAR data, it's fairly standard. The orangey brown that you're looking at is the ground points, and the black or gray points are points that are still in what we call the default or unclassified class. So again, take about 2.5 minutes to run. Generally, of course, what you're going to do in a production environment, you're going to want to do a little bit of QAQC, a little bit of review. You want to make sure that the default parameters are working well for you. There's several different ways that you can do that. Obviously, looking at things in profile is a good way to do this. I've got some forested area here, so I can come in and take a look at 1 meter slice through here, so I can see what that's looking like here. This seems quite a decent job. I don't have any ground points climbing up into the trees. It's really kind of very nicely, following the ground surface. This is not the thickest canopy, but it is canopy. I can look across the buildings over here. Yeah, 1 meter should be fine. Again, so the roofs are excluded. It's generally done a fairly decent job in terms of just showing me the ground and only the ground. Of course, in a real production scenario, I would spend a bit more time than I'm going to spend here today to do this. But let's say we've gone through this, we've looked at this. It looks relatively nice for what we want to do. Depending on the nature of the terrain you're surveying and the kind of project you're doing, you may find from doing this inspection that you do need to do some cleanup or some manual editing of the ground. That's not unusual. This adaptive tin algorithm that I mentioned is really effective for a lot of things, but it can have areas where it has challenges with. You can have some busts in the data. You may need to go in and spend a little bit of time doing some manual cleanup, some manual editing of the data. And we do have a bunch of tools in TrueView EVO that assist you with that. That's really nice for doing that kind of manual editing. Again, we go in more detail in the training and so forth. I'm going to show you one quick tool though on one area, because it does give you a sense of just how relatively straightforward it is to do these kind of cleanups. So if I'm looking here, again, the orangey brown is my ground, the gray is my unclassified. I can see that I missed a patch of data here. I didn't get a ground surface there, and it may be because I'm very close to an edge here. I don't have density. There may be some other reasons as well. But we have a nice tool that you can use if you see something like that. We just call it a cleanup tool. Again, it's a point cloud task, so I could configure these things as I saw or wanted to do. In this case, of course, I'm not going to run it against the whole project area. I'll probably just take, that's a little bit big. I'm just going to use a stamp here. That's fine. Okay. I'm not sure why that backed up on me there. Let me just do this way. I'll just do a polygon instead. So I'm just going to draw a polygon about the area that I want to correct. I want to run this ground cleanup on. And for some reason, that's also not working. Okay, I'll come back to this if I have a little bit at the end. My main point is I wanted to show you there are tools that you can use to do the cleanup, and you should expect to do a little bit of cleanup, especially the more complex the terrain is that you're surveying. If you have a lot of forested areas, if you have a lot of relief in your topography, if you've got a lot of buildings, large and small, the more complex the scene you're scanning, the more you'll expect to do a little bit of cleanup on everything. There's an additional step that we want to do in the workflow with TrueView that's it's really important, especially with working with again, what I call the automotive class of LIDAR, TrueView 410 and other kind of systems. If you've worked with data from these kind of systems, you know that they can have a lot of shot noise. Lewis mentioned this. I think he referred to it as fuzzy. That's typically how I call it as well. It's just, they're just, they're very solid, very good LIDARs. They're just not at the high survey grade level, of an Octec or a Regal system. And you see that if you zoom right in on the data. I'm just going to thicken those points up a little bit so you can see them. Let me just thicken those up so hopefully you can see them a little bit better. And I'm also going to just drop a grid on top of here. This is a 5 centimeter grid. I'm not sure how well it'll be showing up over the webcast, but yeah, each of these grid squares is about 5 centimeters. So you can see even out here in this flat field, it is it's a field, so there is some grass there, but I've got more than 10 centimeters of shot noise. I have that fuzziness to the data. And really, you don't want that, especially if you're going to move on to generating some product from this, if you're going to do contours or something like that. So we've implemented in TrueView EVO, and for those of you who may be customers of ours, also in LP360 Advanced and LP360 SUAS, a new LAS smoothing algorithm. This is quite new. You won't have it in your latest release build, but if you're interested in it, certainly let us know. We're looking for people to help us get this out there and understand how it's working. Works really nicely on this kind of data, Quanergy data, or you could even use it on another system, Velodyne data or something like that. Again, it's run as a point cloud task. And I have it here. It's actually, the implementation I think is really nice. It's actually a very, very simple point cloud task. There's really nothing that the user needs to configure to get it to run nicely, to run properly. You basically just have to tell it what points you want smoothed, how you're going to select those points, and where to write or output the smooth points. So we create a new LAS file from the smoothing algorithm. We don't, so you still have your original source data, and then you just basically go and run that. So I've already done that. That one takes, on this data set, about 4.5 to 5 minutes on my machine to run. But I'll just switch over to the smooth data here. And you can see visually down here, you get an immediate impact, right? So now we're below 5 centimeters and even better in some of these areas. Now this is out in the field. If I go look across the road here, use a little bit narrower profile. Again, you do have to zoom in. We are talking, 10 centimeter stuff. So this is the surface of the road after it's been smoothed. The gridding is 5 centimeters, so you're seeing very, very little residual noise on that hard surface after the smoothing. So again, this is I'll go back to the unsmoothed. This is the unsmoothed on the surface of the road, 10 plus centimeters of noise. And this is the smooth data. So it's really, really effective way to get good quality surfaces from TrueView data. And again, if you're an LP360 advanced user, you have availability. This is available at that level as well, should you want to use it with other noisy data. It works really nicely. So, so I've gone through, I've generated my ground. I've done a little bit of cleanup. I'm not sure why my tool wasn't working there. Live software demo, those things happen. I've smoothed my data so I have a nice surface. I really want to wrap up by creating some output products, because as interesting and, for people who are LIDAR enthusiasts like us, as interesting as all as the front end stuff is, and getting the colorized point cloud and so forth, at the end of the day, you want to be generating a product that someone is going to pay you for, something that they're going to want to use. So there's a variety of ways that you can output different products from your point cloud in TrueView EVO. I want to show you the export wizard, which is where the products are generated, but I'm not going to generate a whole bunch of them here. I've got some examples I'll show us, but the actual exporting is the same approach. So the export wizard is just a tool up here. Again, very flexible in terms of what you may want to output from your data set. We support both outputting the surfaces, of course. If you want to do contours or a DEM or something like that, you can do that from a surface, of course. You can also choose it to output your points, should you need to write out your points in a different file or for a certain area, that kind of thing. Different surface types, as again, we can do a DEM. I'm actually going to generate one of those, show you those: slope, aspect, hill shades, contours. You can even just do an RGB ortho from the point cloud data if you want. That's using a tin surface. We use a slightly different approach, just looking at the points within a grid cell. Then you can do things like a density image or a DC image, which are really effective analytical tools for looking at the quality of your data, the density of your data, and so forth. So you have quite a selection there of what you want to generate. And then for each of the types, there's usually some selection of the different file formats that you may have available. Once you've got that set, you can set a filter here, just as we did with the ground class. So for instance, if I want to do contours of just my ground, I'll just select ground. If I wanted to do some hill shade of my vegetation or something like that, I could do that. So you have all of that same filtering ability within the source points there. And then it's really just indicating where you want to output this data. Generally on a small site, you're going to just go output it for the full layer, but you can use other options. You can zoom in on an area and say, just output from my map view. You can draw a window where you want it outputted. You can even cookie cut by polygons. A lot of options there for what you want to do. You can also load and save these settings. So if you've got a certain product that you always generate at the end, contours is a good example, or a DEM, you can save your standard settings for those and just pull those out. And then it's very straightforward, just telling it where you want to save that data and whether or not you want to put that data back in the map. So of all the products, I'm going to show you a couple of them here. It's the exact same export wizard. You just follow along with that and go ahead and generate and output it. So for example, contours I mentioned, very common output products. So these are, for this data set, these are basically 1 foot contours, 33 centimeter contours. I've applied a little bit of smoothing to them. Again, if you've worked with LIDAR data, you know that the contours can get a little bit, let's say, not aesthetically pleasing. So you do want to do a little bit of smoothing, but we also smooth the ground surface with our smoothing algorithm. So you do get a fairly nice set of contours. These are 1 foot. So, and you can save that as a shape or a CAD file, and that can be your output product. Some of the other products that you can push out, and I'm just going to turn off my, I don't need my flight lines, and I don't need my data set, just so we can focus on the products. You know, I mentioned some of the raster type products. For instance, we can do a hillshade. So here's a hillshade of my ground surface. This can be really helpful in your QAQC to see busts in your surface and so forth. So that can be very useful to generate earlier. We can do a density map. This can take a little bit to understand, but it's really straightforward. You may want to understand what the density of your points are across your project site, often for the ground surface, and you can configure that based on, you know, what values you're looking for. This particular one was generated. I wanted to make sure I wanted to know the areas where I had at least 50 points per square meter on the ground. So that's any pixel that's green, and then the other colors show decreasingly less points down to black being a void. So nothing surprising here, although I did see that I missed these areas where I had busts in my ground that I didn't correct. But I can see under my canopy and so forth, I've got areas of void because I wasn't quite getting through to the ground, and slightly less density in other areas. So that works nicely for that. A DZ image, very effective tool for looking at how well your flight line to flight line are matching. If you're familiar with calibrating airborne LIDARs, terror match workflows, things like that, you'll be familiar with these. Basically, the way you interpret this is each of those pixels, if it's green, it means, I think in this case, I used 9 centimeters, so the ASPRS standard. So it's well within that ASPRS standard for that digital accuracy class. Of course, anywhere you've got structure like forest or buildings, you do tend to get some red because the flight lines will just randomly penetrate in there. So a good analytical tool. And then I'll finish off by just talking a little bit about a DEM, because we can generate a DEM from this. So this is a 50 centimeter DEM. You can output that in a variety of different formats, GeoTIFF, IMG, and so forth. Often, you know, that's a deliverable your client may want exactly, just give me the DEM. What I often like to do, a very standard thing you can do as well, is I can take this DEM and I can actually, it seems a little counterintuitive, but I can bring that back in as a point DEM. So I've taken my points, I've rasterized them, and then I've gone generated a point DEM as well. But the difference is, in terms of from a product perspective, I'm not sure how well, hopefully you're seeing there, those points are now on a regularized grid. That is, I've got an elevation point every 50 centimeters apart. And that can be very effective if you're either you yourself or your client is passing the product off to some downstream modeling software, many of which still don't necessarily work very well with sort of these randomized dense point clouds you get from LIDAR. They're looking for a regularized grid of points, so you can output that very, very quickly, very nicely from that. And again, in a variety of different formats. This one's GeoTIFF. And then where I'll just end up here is I do kind of want to show. So this is the area that was under that canopy on the west side of the project. It's a 0.5 meter DEM that's generated from the TrueView 410 data. As Lewis mentioned, no additional calibration was done beyond the system calibration using the system calibration file in TrueView. I just did a very straightforward default ground classification. I didn't tweak any parameters, and we're still getting quite nice topography beneath that canopy. It's not the thickest canopy in the world, but it's definitely canopy there. You can see the stream structure, you can see some of the side channels and so forth. So I think a really good example of the ability to get really good quality data from a TrueView 410, something that, you know, you can generate good product from in a variety of formats, contours, DEMs, hillshades, you know, something that your customer wants, that they're going to pay you for, unless, you know, you have some of those nice customers who actually just want the full point cloud, which is great as well. So that's towards the end of my half hour. If we have any